Okay.
No, my computer seems to be not doing so good with memory right now.
What?
Hang on a sec, let me crash some stuff. That's how you fix all the things.
Alrighty.
Yay, that seems a little bit better. I'm not exactly happy on the CPU front, but it'll do.
I mean, I like my virtual background, right? It looks real almost.
It does almost look real.
It's great to have you here, Marcella. Oh, Marcella,
Hello.
sorry if I said that wrong. Hello. Hi, everyone that has joined us as well. We might just, I think we're scheduled for 2:10, so we might just wait a couple of minutes to make sure no one is running late for the super important beginning slides, as they are. Where are you from, Marcella? And I'm really sorry if I'm saying that wrong. Where are you from, Steve?
I am from the internet.
From the internet.
No,
it's about right these days.
I'm in regional Victoria, and it looks like my camera is.
It has frozen a little bit again.
Another moment. Just
you might have to go with a cool virtual background like mine as well, Steve.
A virtual green screen.
Possibly. Alrighty, well, another couple of minutes.
I think so. It's running at 900% at the moment. I think I've still got some back-end processes running from the apps we've been building.
You need like oh yeah, I don't even know how to run that. Alrighty, shall we get started?
Yes.
Who's keen? You keen? I'm keen,
Woo!
Steve.
I am.
So good morning or afternoon or evening, wherever you are around the world, folks. Really great to be here today. And thank you for coming and joining us at our little chat. Today we're talking about so first, though, I'd like to begin by acknowledging the traditional owners of the lands on which we meet today, and I'd like to pay my respects to elders past, present, and future. So I'm developer Ali. Great to meet you. I'm a developer advocate here at IBM. I work in Australia. I'm just going to say Australia because I have not actually anywhere. Well, I mean, I'm on the south coast of New South Wales at the moment, but my work is based in Melbourne. So I'm joined here today with the awesome DeveloperSteve, who you might have seen on the circuit. He's been around for a while doing advocacy things. Hello, DeveloperSteve.
Hello, really excited to be here, and super hello to everyone that's joined us today. Really excited to just geek out and share some stuff.
Totally. Love it. So this is our team. We work with a bunch of cool folks here in Australia. Ben Peterson, our supreme leader, as we sometimes call him. He's a legend though. G Chan, we'll also work closely with Kongi, great technical expertise. Rahul's our marketing helper, and there's me and DeveloperSteve again. How about that? So what we do as developer advocates is we love to support communities. So we do a lot of local community events. We recently wrapped up the IBM Call for Code, and the finalists for have just been announced for both the university track and the global track. If you haven't heard of Call for Code before, it's a hackathon on tech for good. So this year was focused around climate change and COVID solutions. Some really cool stuff came out. And to be honest, it was really awesome seeing like an idea that someone had in the first hour or two of coming to one of our little hackathons in Australia be built out so far, so many months later, and actually on that, and see them go on their journey to, you know, creating almost a product. And actually a couple of the winners from the last 2 years, 2018 and 2019, were soon deploying as real fully fledged products in Australia. So maybe you could talk about that a bit, Steve.
No, we had some amazing submissions this year, particularly for the APAC region. So, and a lot of really, really cool submissions that we're now keen to work with folks to help them build out. And as Ali said, we're close to announcing the finals, the regional finals. So stay tuned for that one. And if you haven't yet, if you want to find out more, check out developer.ibm.com/.
Definitely. And we even held our workshop, our hackathons in a cool virtual spaceship. So obviously, given the climate, couldn't have them in real life, but this was as close as we got. Could say it was out of this world, even.
Hey, that's my favorite line to use. FYI, there will be, I do have a whole bunch of developer puns, so stay tuned for.
We do love a good pun.
If not, if you want some more at the end, please hit me up, and we'll get to. We've got a whole bunch of stuff to get through. Anyway, I don't want to give away.
I do like to joke that I wear this hat because Steve has a lot of puns, so it saves me from like hurting myself all the time.
That's true.
So we also have the IBM Academic Initiative, so you can learn the skills for today's job market. Check that out if you want as well. It's at ibm.com/academic, and we've got an IBM startup program. You can get in IBM cloud credits, which is not nothing. So that's pretty cool as well. So anyway, what are we doing today, Steve? Cloud native.
We love cloud native. So today we're talking about cloud native. We're touching on containers, of course, because that's all part of it as well. And in particular, Kubernetes and OpenShift. Really excited to share some fun OpenShift stuff with you all today. And also some OpenShift toolage, which is always good. And what this is not, I love this slide.
Great.
This is not an introduction to Kubernetes, although we are going to be touching on it a little bit today. It is not setting up and administering an OpenShift cluster, although we are happy to talk about that. But yeah, that's not a today thing. And then this is definitely not a sales pitch, marketing pitch, or cricket pitch. I love that pitch.
That's just not cricket, honestly.
No, it totally isn't. And yeah, like I said, we're literally here today to geek out. And if you do have any questions, please put it into the chat. One of us will get to it while we're co-presenting. And if not, we're happy just to geek out with folks afterwards. We do have a booth in the exhibitors hall in the tab on the left-hand side. So even after this, if you want to come chat all the things, please come and talk to us.
You can find us on all the social medias too if you miss us here. So yeah, feel free to ask questions. Let's get on with the show. So cloud native, I love this picture. What is cloud native though? Oh, actually, going back a step here. I think this slide's for you, Steve. You've been around for a while, since the late 90s maybe, I could say.
You know that thing where I said my PowerPoint might crash? Guess what it just did? It did. It seems to be the day for. If you give me 30 seconds.
Sure. Yeah, no problem. In the meantime, so cloud native is really this new concept architecture. aiming to use microservices, aiming to be scalable. And it's basically technologies that can empower organizations to build and run scalable applications in a dynamic environment. So you can run them across public, private, and hybrid clouds. It's not limited to, I have to have a modern app with all the modern languages. No, that's not true. You can still run a great DevOps pipeline and run in an agile cloud native way. And use this tooling even on servers that are still on premise, are still running on private cloud, or across different cloud providers. So I just want to make that clear. And one of the reasons cloud natives came about, and I guess this is talking a little bit to this slide and the evolution of application architectures, was traditionally you kind of had these siloed teams, like that's the way we worked in the 80s and 90s, and we had like a devs trying to get all the code done in an ops team. And they basically had competing interests. So devs wanted to, and I'm a dev, so I'm going to probably speak a little bit to that. But ops team, totally understand where you're coming from. No attacks here. So I'm a developer and I used to write immaculate code, and I'm going to say immaculate code, and it would get stuck in this phase where it'd ping pong to operations and it'd ping pong back because operations are looking at security. They want it fully tested, and definitely you want that as a business model. And developers are like, but I want to develop new features, not continually bug fix. So this is, DevOps is kind of a way, and Cloud Native on top of that is a way of bringing these two teams together and, enabling everyone to have a product focused mindset rather than, kind of ping-ponging and passing the buck. Like, I was about to say something that I'm not going to say.
No, I think that a lot of what we're talking about today is the evolution of the industry as it's grown.
Exactly.
And many of you will probably remember the days of SOAP APIs. They were great, weren't they?
I mean, great for cleaning. Is that what
for cleaning. XML formatting, for example, kind of was a lot easier inside a REST world. So and I think that is what we're talking about today, is demonstrating how the industry has evolved as it's needed to go to scale.
Yeah, definitely. And how it enables so much more in just one automation flow as well, which is awesome. So that's what we're talking about today, cloud native technologies. That focus on the how applications are created and deployed rather than where they're deployed. We don't need to know that. We just need to know that it runs, it's tested well, it's secure, it's got governance in it, and, it delivers great business value. So
for those, I was going to say, for those that are just joining us, if you have any questions, please put them in the chat. Just saw some folks through, and welcome.
Welcome everyone. Thanks for joining us. So why is cloud native important to API development? And I guess I've kind of answered this a little bit, but cloud native creates this agnostic framework, and that's important, that enables like scalable, flexible, agile, portable, extensible, all the buzzwords, but also really important factors in a development, life cycle. So it creates observable flows as well. So as we'll touch on a little bit later, you can log things, you can see your entire mesh. You can add governance and security in that, and that's kind of a new field where DevOps and Cloud Native is going as well, which is awesome. So the big thing for me is sorry, Steve, 1 second. they promote continuous innovation, and they're also really cool for open source adoption. And like I mentioned before, they do enable the opportunity for multi-cloud approach.
Yeah, and I think that multi-cloud was exactly where I was going to go, particularly for, I've been a CTO before, so needing to sort of govern and guide infrastructure to scale, but also from a PCI standpoint for particularly, the financial industry, et cetera. What we're talking about today is really cool because you can have componentized, isolated projects where you have different governance or different regulatory monitoring on different environments. So no spoilers.
Super important in enterprise. But I like that the small apps as well, and sorry, I'm off track again, also enable that kind of team environment. So you can work with a small team and you can be agile. You're not waiting on 100 other developers to do things, which is, traditionally maybe how it was. So key attributes of a cloud native application, they're packaged as lightweight containers. So Docker, Kubernetes. They're developed with languages and frameworks. They don't have to be, but generally are. So they're designed as loosely coupled microservices. So this is what we were talking about, having everything. They're functioned, basically. So instead of working, your teams having one function each, instead your applications have one function each. Mostly how you would code as well. Like you want to be able to copy that code over somewhere else. So that's how they work. So centered around APIs, super important because that means you can build, you can connect across microservices, you can bring in third-party microservices, which is pretty awesome. So ML analytics come to mind, security and governance, like Steve was alluding to as well. They're isolated from the server and operating system, and they're deployed on, a cloud infrastructure generally, and managed through that cool DevOps agile lifecycle.
And I think the 0.7 there, super important, elasticity. Like you always build it, no matter whether you're a startup or a big enterprise. And a lot of enterprise projects start off as small MVPs, just testing a concept, testing an idea. But you always build small for that big expansion as users adopt your app or whatever you're building out. So, and again, API is no different. You can route different infrastructure through the platform to different resources inside your stack.
Yeah, super important point, actually. And I don't know, and I'm sure many of you have had this experience. I can't count the number of times someone said, oh, just build me this little POC that ends up going into production a couple of months later. And you're like, if I'd known you had an end goal. So, every time someone asks me about a POC now, I'm like, it's going to take longer than that. I'm sure there's a few of you out there that have experienced that as well. So microservices architecture, what the hell is that? So generally, large it's not a microservice, it's not a service for ants. So large monoliths are broken down generally into many small services. So like I was saying before, you will take the functionality of the monolith and split that down. So you've got potentially your ML side, you've got an analytics side, you've got your main user-facing app, whatever it is, you break it down into these many different small services that teams can then optimize to it says it there actually, optimize for a single function or business capability. And that means that gives power back to the teams as well to be able to keep innovating without having to wait for other parts of that code to be finished and keep delivering endpoints for business and bringing business value. So smart endpoints, dumb pipes, and as you were mentioning before, Steve, decentralized government and data management.
Which is really, that decentralized management and in the governance piece, particularly with needing to look at things like PCI, like totally critical.
Yeah, and getting more and more important these days and more consideration. So making it easy and automating that, I mean, as a developer, that's what I want. I don't want to be dealing with that every time I push something. So, and even as a business exec, you want those things automated. Like it works both ways. Even as operations, you don't want to be dealing with that either. So what is a 12-factor app? So this is a methodology for constructing cloud-based applications, basically. They use the 12-factor application to describe the set of principles and best practices that developers can follow to build applications for modern cloud environments. So some of these things are pretty obvious. For example, all your code should be tracked in source code management system like GitHub. Your build, release, and run should be in separate stages. And you should treat logs as event streams, which is kind of a key point. And one of the key things to note is when you're writing cognitive apps, you should be able to understand these practices and incorporate what's appropriate for your app. And that's the same with the Agile way of working. You need to incorporate the features of Agile that work for you and your team, not just, blindly take the Bible, I would say.
Yeah, exactly. Deploy fast and scale even faster.
Exactly. Remember what your end goal is. Like businesses are successful because they're always innovating. And that's what you want to allow your team and empower your team to do, not get stuck in config and testing and error logs and trying to find the error logs. And I don't know how many times I've run through them. So we want to avoid those pain points. So we've already mentioned this, monolith versus microservice. Sorry, go Steve.
Oh, I was going to say there are times where monolith might make sense. Like if you've got like heavy lifting infrastructure that needs to run on monolith, I mean, cool, that's totally fine. I think what we're talking about here is sort of breaking that out into smaller units. And even if you think, and again, spoilers, because I've already read the script, but if you think A/B testing, you can have different pod infrastructure running with different API routes so that you can A/B test or even give different access to different levels of partners or different clients that you want different access, them to have different access. So even down to the key level, you can run through different routing.
Yeah, and that's a really good point. Just because you've got a monolith and it makes sense for it to be a monolith doesn't mean the rest of that monolith pipeline can't be expanded and made better. Like you said, you can run A/B testing, you can have different pods. You can still use a monolith. There's no reason it can't be cloud native monolith. But the idea behind cloud native really is in the microservices architecture and breaking it down for easier use and empowering your teams as well. So there's some really cool microservices examples out there. I'm sure everyone's probably had a look at the Netflix example, and they've been massive, and they do a really great job on answering a lot of these questions. So Netflix was one of the earliest adopters of microservices, and this term really didn't even kind of exist when Netflix began, but today it is really paving the way, and it's powered by an architecture featuring an API gateway that handles about 2 billion API edge requests every day, and they're handled by 500 plus microservices. And that's why we can all watch Netflix whenever we want, generally.
It's true. And to think they started with a DVD post-out service originally, and now like they reach, the entire world from their platform.
Exactly. They disrupted the industry. They changed the way they were working. Like it's really a powerful testament to that way of doing things.
Exactly. Actually, just back on that other slide, one of the recent announcements we had is a partnership between IBM and Coke, where we're helping them deploy some of the methodologies that we're talking about today, in particular, OpenShift, hybrid cloud, and then there's some really cool AI and IoT infrastructure going alongside that, which plugs in like really well into what we're talking about today.
So we're not just having Coke with our Netflix. That's what that's about.
That's true, yes.
So the second part of cloud native, so we've got microservices, break things down into easily accessible things. The second part of that is containerizing them, because you want to be able to, provide process isolation. You want to be able to deploy these apps on any platform, anywhere, basically. So containerization really allows you to do that. And by containerization, we're talking on two levels, really, like Dockerizing your apps and then Kubernetes as well. The initial idea of containers was to slice up an operating system so that it can securely run multiple applications without them interfering with one another, basically. So this kind of isolation is accomplished with like namespaces, control groups, which is originally a Linux kernel feature. So namespaces, they allow the different components of the operating system to be sliced up, and that creates isolated workspaces. So, and control groups then allow that governance that we've been talking about, that fine-grained control of resource utilization. Oh, well, not governance exactly, but that control over, what am I saying here, Steve?
more flexible control over the infrastructure.
Yeah. Exactly, which is what you want from an ops perspective, definitely, and from, makes it easy for everyone. So, and you know what resources you're consuming, etc. So containers aren't a new idea, are they, Steve?
No, they're not. They've been rising in popularity since 2013. That was from the rise of Docker. And it hasn't stopped growing. Like I said, a lot of what we've been talking about today, and particularly being around the industry for a while, like you'll see like these, the evolution of infrastructure like this, just out of the need to handle scale and also adaptability as new things come along and basically plug into the infrastructure you're deploying. Which is one of the things I love about OpenShift is literally, again, spoilers, we'll get to these slides. But yeah, that's one of the things I love the most is it's so adaptable. It is basically that universal multi-tool almost.
Yeah, exactly. And, those kind of container systems don't require multiple operating systems either. So that's a big edge over some other ways of doing things. So virtual machines versus containers, is that what we're doing?
That is a common question.
What's the difference?
So if we have a look at virtual machine diagram on the left, hypervisor runs on top of the infrastructure. So resources such as CPU and memory can be these virtual machines running on the hardware. And then within each virtual machine runs a unique guest operating system. Each VM has its own binaries, libraries, application that it services. The apps inside are not isolated. Multiple versions would have multiple conflicting dependencies.
Yeah, and they don't share anything either. So even if App 1 and App 2 have the same dependencies, they don't share them. So obviously that adds to costs in your storage as well.
Yeah, and from a developer standpoint, even like if you think library versions, getting your code to run inside multiple versions of a library. Yeah, that's the way I pull out a lot of hair.
Yep, definitely have been there also. Wait, what version are we running? Is that the problem? Like 2 a.m. in the morning?
15.3.
No, thank you. So containers really isolate this project and also give you the ability to kind of share those dependencies as well. So why containers? Well, containers provide portability and guarantee consistency, super important, across environments, like we were saying. Don't want to be pulling out my hair at 2 a.m. because we're checking each other's environments. Versions, yeah. So by putting everything into this single package, you isolate the microservice and its dependencies from the underlying infrastructure, as we've mentioned. But it's worth mentioning again because it's an important point even. So containerized workloads eliminate the expense of pre-configuring each environment as well with frameworks, software libraries, and runtime engines. So obviously that creates efficiency and it makes for an automatable runtime as well. So by sharing the underlying operating system and host resources, containers have a much smaller footprint than a full virtual machine. Also an important point, especially if businesses are looking at costs. And that's slowing down the line from the top. There's too much cost, cut the costs. Well, we can. So containers share the operating system kernels. So they're similar in size, meaning they can be spun up quickly, another important point, and they support cloud native applications.
If you think of the whole approach to lift and shift too, and as Ali said, having multi-cloud infrastructure underpin your stack, it just means you can pick up things and move them across clouds if you need to as well, a lot easier.
Yeah.
And
go ahead.
Sorry, just important to note, it was literally like I just had an idea thing. But yeah, that also spans not only to clouds, but also onto prem as well. And as for some announcements we made earlier in the year, onto edge, which is emerging again.
Yeah, definitely.
Amazing to see.
Yeah, no, and awesome technology. And like Steve said, this doesn't just apply to new services that you're building. This is, you can use anything for it. And it will help. So yes, that was a very good point, Ali. I've just got this meme in my head when you said lift and shift of people lifting and then throwing it over the river. Sorry, that's why I'm distracted.
I mean, no, it's very similar to that though, because you are literally porting, not even porting, moving whole apps like across to different infrastructure on the same stack.
Exactly. So your basic Docker commands, you've got build, tag, images, run, and push and pull. So these are the common Docker CLI commands, and I'm sure a lot of you out there could probably tell me way more commands than that because you've used it a lot. But the is used just for those who don't have a general idea as well, and we don't all, and that's why we're here to learn new things. So the Docker build command is used to create container images. Developers provide a Docker file, and this serves as the blueprint for building a container image. The Docker build command then takes that file and performs the heavy lifting to build an image. So now I'm going to have another meme in my head of trying to lift something heavy and not be, no, anyway. So my head did it. So the command also enables users to tag their images, which means giving them a name. So you can directly tag images using the Docker tag command as well. So if you have an existing image that you want to rename, for example, or if you received this image from someone else, or if you want to store it in another location, you can use the tag command to overwrite the existing. The tag command doesn't overwrite the existing image. It will just so we'll create a new tag that points to that same image. The images command will list all of the images, their repos and tags and their sizes. The Docker run command is used to run a container. So that's pretty fun. It's actually pretty easy to get set up with Docker. So you can try it out. There's plenty of cool tutorials out there on it. The Docker run command is used to run a container. So if you're developing container images and you want to test an image that you've developed, you can run it as a container locally, which is awesome. And the command is perfectly suited for doing that, basically. So finally, we have the push and pull commands. These commands are used for storing images in a remote location and then retrieving those images, much like you do with your Git commands. Alrighty, so container orchestration. So now that we've learned the basics of containers pretty much, or what is container orchestration? And how do we use it to create complex environments with many running containers? So usually you'll start with one container and over time you'll deploy more apps, add more components and projects. So one becomes like many containers. And that's the idea. And at first it's quite manageable and then it starts to get overwhelming and then pretty chaotic. And then we're back to pulling our hair out at 2 a.m. So this is where container orchestration becomes pretty necessary and makes things easy for you so you can keep your lovely hair and your nails, which I don't always do.
Well, yeah, and just to add to that too, one of the things, particularly in the early days of orchestrating, is also dealing with log management. So as your environment scales, you have a lot more logs being produced, so being able to identify issues and such. But we're going to show you a really easy way to do that today, and then also give you a way to get hands-on with it and play with it, which is kind of cool. But yeah, stay tuned. Again, spoilers. I always give away the spoilers. So
yeah, like you were saying, container orchestration tools on top of that can also perform health checks to ensure that applications are running. And can take necessary actions when these checks fail. So you're not getting, you're not on call at 2 a.m. again. Oh, this has gone down. Can you please fix it? It will try and get itself back up, which is also another cool feature. So enter Kubernetes. So although several container orchestration tools exist, Kubernetes is really the established platform of choice for developers. And it's also known as K8s. So you've seen that around before, and honestly, as Steve can tell you, I really hate acronyms. I hate them. I'm never sure what they are. There's so many different acronyms for the same thing. Anyway, I digress. But the Kubernetes one is kind of cool. K stands for Kubernetes. So it's orchestration, but for containers, not VMs or machines, which is why it's grown so popular. Oh, there we go. And that's a quote from Mark Hildebrand, who is a Red Hat evangelist, or advocate, whichever way you want to put it. Exactly. So what is Kubernetes, Steve?
So Web has defined Kubernetes as an open source system for automating deployment, operators, and scaling of containerized applications across multiple hosts. Woo, multi-cloud. And it was originally a Google open source project that had container orchestration at its core and had the added functionality that allowed for IT operators to deploy containers, have them scale up or down, and generally abstract a way of underlying infrastructure. So just being able to scale amazingly fast, which I'm a big fan of, particularly in the current environment and for API use in particular, just because it can handle the load as it needs to.
Yeah, exactly. And whilst it was originally a Google open source project, heaps of people support this now. So IBM, it's open source, obviously. So there's heaps of companies and big industries that support developing this infrastructure now, including
very industry standard.
Exactly,
yeah,
exactly.
Across the board.
So some components of Kubernetes. Do you want to run us through these, Steve?
I do. So basically, you have a cluster. So a cluster is a set of nodes that at least one master node, just to be the controller, and several worker nodes, sometimes referred to as minions. But I mean, worker nodes is fine. Everyone knows what that is. That can be virtual or physical machines. Then you've got the Kubernetes main node. So the main node manages the scheduling and deployment of application instances across nodes, and the full set of services the master node runs is known as the control plane. And a lot of this will be very similar to the mainframe days. And again, this sort of speaks to the way the industry's evolved and sort of reiteratively built on itself. So figuring out what works, deploying new, building new projects on top of that. So, and OpenShift has kind of come out of a lot of that as well. Then you've got the kubelet, which sounds like it's from Pokemon Go, but it is not. It could almost be. So each Kubernetes node runs an agent process called a kubelet that is responsible for managing the state of the node. So starting, stopping, maintaining application containers based on the instructions from the control plane. A kubelet receives all of its information from the Kubernetes API server, which is really cool because if you use, in particular, the OpenShift stack to deploy API infrastructure on, you can use APIs to deploy APIs, and that is really meta. Then you've also got pods, which is the basic scheduling unit, which consists of one or more containers guaranteed to be co-located on the host machine and able to share resources. So like Ali was saying, you can have shared libraries, shared repositories, all contained within the same stack or network, basically. And then there's deployments, replicas, replica sets, etc. And deployment is a YAML object, and we love YAML, particularly at API days. YAML's my favorite. YAML object that defines the pods and the number of container instances called replicas for each pod. You can define the number of replicas you want to have running in a cluster via replica set.
So quick quiz, what does YAML stand for, Steve?
I love this one. Yet another Markdown language.
That's not bad for an acronym. Don't mind that.
I know. And it's so industry standard now. So,
and missed opportunity. I feel like I should have had some little minions like arrows there, but I'll add it to the next time. So components of Kubernetes. So on the left side of this diagram is the control plane, which makes decisions about the cluster and detects and responds to events in the cluster. So that's where the minions are. An example of a decision made by the control plane is scheduling of workloads. So an example of responding to an event is creating new resources when an application is deployed. The control plane consists of several components. Then first is the Kubernetes API server, which Steve was just talking about, which exposes the Kubernetes API. And all communication in the cluster utilizes this API. And I do love a good, clear API to use. So it makes things easy for me.
We might just have to speed up a bit. I just realized we've already got 17 minutes left and we're already halfway.
Oh, we're just so excitable.
Yeah, we kind of talked a bit on the slides, but yeah, so basically Kubernetes is the service that underpins like all the orchestration side of things, but it wasn't really built for developers in mind. However, we have a way to be able to do that really easy. Oh, I skipped the next few slides. Okay,
we're skipping benefits and challenges. Yep, right. So enter OpenShift.
Oh, we almost did that in sync.
We practiced that before. No. So you can consider basically that Kubernetes is probably your engine. And if you consider it that way, then OpenShift is your car, which really makes the background image make a lot more sense as well. So OpenShift is basically a platform built on top of Kubernetes. So Kubernetes, like Steve said, there's not a lot there for developers, and it can get complicated in all the configs you have to do. So this is where OpenShift came from. So Red Hat OpenShift, like I said, is built on top of Kubernetes and provides various additional capabilities to Kubernetes, including OpenShift offers consistent security, super important these days, built-in monitoring, again, don't want to be looking through logs at 2 a.m., centralized policy management and compatibility with Kubernetes container workloads. It's fast, it enables self-service provisioning, and it integrates with a variety of tools, and we're going to touch on a few of those hopefully soon. So there's plenty of ways to build applications in the platform. There's multi-tenancy isolation for different teams working on different projects. There's self-service infrastructure, which allows developers to provision on demand. And developers don't have to wait on a request from the ops team to get ready. So avoiding this whole ping-ponging and blaming each other game. So it also provides a consistent environment. So OpenShift makes sure environment is consistent from operating system to libraries, runtime versions, Java runtimes, and Tomcat, to remove the risks that originate from inconsistent environments. Fully automated CI/CD pipeline, love that. So devs can choose their own containerized apps or contribute their app and allow OpenShift to containerize and deploy for them. Thank you, OpenShift. So I can get back to developing code.
And of course, importantly, it's open sourced, and they want it. They want people to contribute. So if you haven't yet checked it out, like there's a whole repo on that. But yeah, we need to speed up because we do.
So we've already gone through this. Kubernetes is OpenShift for the developers. So a bit of OpenShift history, which you can look up.
I just want to go back to that last slide. This is really cool because this isn't like a new project. It has been around for a number of years now, very widely industry adopted. And again, it's built on top of open source stuff like Kubernetes. But version 1 went live in 2011 and version 4 recently went live as well. So it has got a lot of heavy support from wider industry as well, which is amazing.
I do love how much adoption it's got, like, as well. Look at the growth graphs. It's really cool.
Yeah, which is cool. We probably don't need to go through.
Okay.
Pods.
Yep. So I'll just skip past. Maybe you can just give a quick overview on those
projects. So basically, what we're just talking about with the fundamentals of Kubernetes, the best part is inside OpenShift, a lot of it's managed for you as part of the deployment. The one thing, if you can go to the project slide, where is it? Basically, one of the things I love the most is that project. So having that isolation, if you think like those top tier integrators, even from an API point of view, having those top tier integrators means into separate projects that's off the main route. It just means, and you can tie that to an API key. So as they come in, OpenShift would be able to route to a different internal endpoint. So you can isolate those users from your main regular API traffic, and that way they're isolated into their own environment almost. Still can do the same things. It's just going to be routing into different infrastructure, which for compliance and governance, like particularly PCI industry, PCI side of things, yeah, for the financial industry, is really cool.
And even from a simpler standpoint, just going to test and then dev and then production, like that's another way you can use them as well. Yep.
We can probably go to 48.
Okay, we're going to 48, everyone.
We're being agile.
Totally are. So the goal of OpenShift is to provide the best experience for developers and sysadmins developing, deploying, and running applications. And we've spoken about that a lot, and I'm sure you have all experienced that firsthand as well. So it makes it easy for the developers to and easy for operators to deploy containers for both development and production workloads. Look, here's a gift.
I love that gift. So cool. We normally would, with a bit more time, get hands-on with playing with OpenShift. But so here's some links we prepared earlier. Now I'm going to drop those into the chat.
Perfect.
Let me just copy paste. Oh, that was the wrong chat.
Yeah, so these are some great links for learning OpenShift. So IBM and Red Hat have recently deployed a marketplace as well, which you can take a look at. But what I love, and when I was first learning OpenShift, what you can learn it in the browser. You don't have to deploy your own OpenShift cluster. You can basically go to learn.openshift.com. And it'll deploy a cluster for you, and you can start learning from there, which is super cool.
I pasted the wrong link, FYI, but you probably all saw that. That was the link for this session. Yeah, so that's learn.openshift.com. There's some really cool hands-on in-browser tutorials that you can get hands-on with OpenShift without actually deploying any infrastructure, which is kind of fun. And it doesn't matter if you break anything, you can just reload the session,
exactly.
which is also amazing.
Refresh.
Particularly when it's starting out. The first one, I would definitely start with the first one, just using OpenShift. You can open a console and start playing around with some stuff,
super cool.
Is amazing.
And there's even a tutorial that'll take you through different commands and things like that, which you know, is great. I love that kind of learning. So there's some OpenShift tools that we want to mention as well. So source to image is one of them. It's a tool for building reproducible Docker images. Source to image is a framework that makes it easy to write images using source code as an input and produces the new image that runs the assembled application as output. So developers write code using existing development tools such as Maven, NPM, Bower, pip, Dockerfile. I could go through many of them, and then access the OpenShift web CLI or IDE to create an app from the code. S2I combines source code with a builder image, so language and application runtimes, and stores the resulting application image in the image registry. This image registry by default is the OpenShift integrated Docker registry. However, users can also configure that to push the built images to third-party registries like Docker Hub, Nexus, Artifactory, Amazon, whatever you like. OpenShift monitors the builder images in the image registry and can automatically rebuild the application images in the language, e.g. like Java or Ruby or one of the many others I could mention, or application runtime like JBoss, EAP, Tomcat image is updated. So for example, due to security patches. Love that as well. Like a security patches doesn't bring down your whole server. So OpenShift automates the deployment of application containers across multiple hosts via Kubernetes, and users can trigger deployments, rollback, configure AB like Steve was talking about, or other custom deployments. There we go. So this is the OpenShift web console.
It's pretty cool.
It is
very easy to navigate. But yeah, get hands-on with it at learn.openshift, like through the magic of a browser. That you don't even have to, well, I mean, it would be a browser anyway, but you don't have to deploy the underlying infrastructure to be able to get hands-on with it. You can run it locally as well. There's a code-ready container that Red Hat has available, which lets you run on your local machine. So once you get familiar with the nuances on how everything works, and it's really easy, like the console, you can create a project and be able to simulate some apps. But then if you want to get down to the app deployment side of things, you can grab a code-ready container, run on your local, and just test out to see how it works. And of course, get some cloud infrastructure and start running it.
Yep, and start scaling, using pods, create projects, view log files if you want to do that.
Oh, that's the next slide, which is really cool. Because anyone that's tried to run Kubernetes stacks straight before, like grabbing the logs and stuff, like there's some really good tools that do a lot of the logging side of things. It's built into OpenShift as well.
It's the word integrated. Love it.
It is. And then, there's some really cool tools for developers to be able to get hands-on and deploy stuff just through command line. Which is amazing. In particular, one called there's CRC as well. Code-ready containers. Woo.
Yep. So you spoke about this a second ago.
But yeah, it comes with comes with the tools for developers to be able to build, deploy, test, check infrastructure. All the command line. And again, that's in the learn.openshift tutorial as well. It actually does. It gives you the ability to use command line in the browser and then also be able to do web console stuff as well.
So I'm pretty sure this is one of your jokes, Steve. So I'll just.
The command line tool you run locally is called DOC, not to be confused with the TV show, of course. But yeah, like I was saying, it basically helps devs get hands-on with the infrastructure they're able to access as part of their user group permissioning.
Yep.
So, which is all set up in
OC, OpenShift, Clay, just to be clear, not Orange County. So that's what it looks like right there, as Steve said. There's also command line tools. So Odo is a CLI tool. Oh, Apidays we're talking about here. Odo is a CLI tool for developers who are writing, building, and deploying applications on OpenShift. And developers get an opinionated CLI tool that supports fast and iterative development, what we're looking for. Odo abstracts away Kubernetes and OpenShift concepts so developers can then focus on what's important to them. Coding. Yay. So that's the CI/CD pipeline, basically continuous integration, continuous delivery, continuous deployment. And I would also add continuous innovation to this pipeline, or I like to add it when I talk about CI/CD, because it's true if it's done well. It's not just automated end to end, but it also empowers your teams to work how they want to work. Like I was just saying, I get to code again. So as we're talking about CI/CD, Tekton is one of the great tools for a CI/CD pipeline. And because we're shifting towards a more container-based, Kubernetes-based architecture now, Tekton's becoming more popular as it's cloud native. So it was deliberately developed for these sort of tools. And it's open source as well, which is cool. It actually came out of Knative, so Kubernetes native originally, and then it got forked off as its own project. So it kind of gives you an idea of kind of how useful it is. So I might skip that one.
That's right.
So Tekton runs on Kubernetes. Like I said, it uses containers as the building blocks. It's typed. It's composable. Tekton concepts build upon each other, and it's decoupled. So the tasks which make up a pipeline can easily be run in isolation, which is what we've been talking to you about a lot before. So when we're talking about this whole infrastructure as code, this whole cloud native, microservices, containers, OpenShift for helping to orchestrate those containers, and running the engine, basically, what we're looking at is the cultural change consideration get out of it. And I have spoken a little bit about that today as well. So like I said, you get smaller teams with a broader scope. So as a developer in a small team working on this one thing, I have the ability to deploy a lot more often. So I'm not just deploying on a release management lifecycle, which is usually on a Friday afternoon. And I know, Steve, you've got a rule for that.
I do. Yeah, if I mean, we always get asked. We work with a lot of startups and developers in all sorts of company life or app life, and yeah, the one thing we always get asked is, which tool should I use? Which language is the right language? And just something I know from experience is, if you can support it on a Friday night while halfway through a game of PUBG, then it is the right tool for you. Yeah, ultimately, like, you will be the one supporting the tools that you're building. So that's. Yep. And particularly, like, I come from digital agency world, as does Ali as well. Yeah, particularly from that world, it's like, yeah, if you can support it, halfway through a game, then you can totally support it. Well, it's the right tool.
Exactly.
And just on that cultural change too, if this is relatively new but of interest, these concepts we're talking about today, one of the great ways to be able to test this is just by using it with a small project, be it a proof of concept or like an MVP. So start small, just like a stack. Start small but think big. Yeah,
totally. And that's another good rule of thumb of yours, I like, Steve. So yeah, it builds trust. Teams own their own metrics, top-down support, and rewards are based on results instead of just being based on compliance. So building innovation again and delivering business value faster. So your execs will also love you, which is great.
We are almost out of time, okay. But I'm going to give everyone another thing. If you want to get hands-on with CI/CD, there's a really cool tutorial that I'm now going to paste, and I've got the right link this time. Oh, it's copied it twice. So my computer is really unhappy today.
Talks about being out of time and then goes off on a complete tangent. Anyway, we will post some links after this, or hit us up. We're always around. So there's a Node-RED starter application, which is super cool. And I know for those of you who haven't heard of Node-RED, it's kind of a drag and drop GUI application, which but really powerful, and you can write your own functions and things like that for it. So check it out if you haven't heard of it. But here's a good starter application for learning that and getting hands-on with CI/CD using that. So basically,
I can copy paste.
Can't copy paste. That's okay.
I don't know what's going on back here. But if you check out developer.ibm.com, there's one of my favorite open source projects we have called Node-RED. Well, I mean, OpenShift is favorite too, but Node-RED's like the MVP prototyping tool of hackathons and just testing new ideas. So you get to deploy that onto IBM free tier, and then as part of that, it automatically deploys some continuous delivery for you to play with, some CI/CD.
So developer.ibm.com, you'll find it on as well. They've also got the OpenShift Immersive Labs, which we were talking about a little bit before, and you will find on Red Hat OpenShift workshops. As for us, we also run workshops and events. Like we were saying at the beginning, we are big fans of supporting the local community. So if you ever need a speaker, please hit us up, or you want help with a virtual venue, we also do those. But our upcoming ones, we've got an Oz IoT meetup, which really, I guess we could call it Global IoT. That's on the 7th of October. So some super cool people doing super cool IoT things at that one and talking about it. And we've also got the IBM Developer Meetup. Got some amazing speakers talking about AI in health. So from the research labs at IBM and also from the University of Sydney. So that'll be a super interesting topic as well. And sorry, that's on the 14th of October, so the week after, if you can join us then. That's in Australian Eastern Standard Time, but yeah, it should translate fairly well for Jakarta. So thank you to everyone for listening to us. Sorry we went a little long there. And as always, remember, be excellent to each other and use your tech superpowers for good.
Thank you. Come say hi in the booth because we are literally out of time.
Yes. Thanks, everyone.